Hello everyone, this is Wei. I'm currently a postdoc at FSU. I'm going to introduce the Lakeshore example simulating with ArcNLET-Py. These three of us developed ArcNLET-Py. Our emails are here. If you have any question, please feel free to contact us. There are three parts to this presentation. The first part is a brief introduction to ArcNLET-Py. The second part is a Lakeshore example, and the third part will introduce new features. Okay, let's begin with the first part. I will start with history of ArcNLET. The first version of ArcNLET was developed in June 2011 by Dr. Welsh and Dr. Ye with the funding of Florida Department of Environmental Protection. The first version of ArcNLET was developed for ArcMap 9. Then 2 months later, ArcNLET 1.1 was released for ArcMap 10. Next year, Dr. Ye and Dr. Wang developed a visual model which can simulate nitrate reactive transport in vital zone. In 2013, ArcNLET 2 was developed by adding a new function of Monte Carlo simulation. Then in 2015, Dr. Zhu and Dr. Ye developed ArcNLET 3. It can simulate reactive transport of both ammonia and nitrate in vital zone and groundwater. However, ArcMap will not be updated anymore, and the source code of ArcNLET is already outdated. Therefore, last month we developed ArcNLET-Py, which is a new version written by Python for ArcGIS Pro. Here are some websites for ArcNLET. The first site is highly recommended. This is Dr. Ye's YouTube. He made a dozen videos that introduce in great detail of ArcNLET from principle to application. It's this one. You can find ArcNLET training videos. The second site is the GitHub webpage for ArcNLET-Py. After opening this webpage, you will find a README file. And there is a link here, user manual. If you click this is an online user manual. And the third page is FSU's ArcNLET site. Here, you can find software manual and some examples. This webpage is for all the versions of ArcNLET, but it's useful. The purpose of this video is to describe how to complete a simulation using ArcNLET-Py. This is only a demo for a new version. This video can be used for ArcNLET users switching from the old version to the new version. If you are new to ArcNLET, you can follow along and learn how to run a demo, but I won't cover the principles of ArcNLET. If you want to understand the principle, please see Dr. Ye's video or our technical manual. Okay, let's start with the Lakeshore example. The Lakeshore neighborhood is located in Jacksonville, Florida. And the study area is here. The study area has a total of 265 septic tanks as shown in the figure. Our goal is to calculate the nitrate pollution of these septic tanks. This is the webpage of ArcNLET-Py on GitHub. I will explain the organization of the file. It's very important. Okay, this is the webpage. The first folder, idea folder, is something setting for editing and debugging the code. Never mind. The folder ArcNLET is used to hold Python code. The example folder is used to store data for the Lakeshore example. The training folder is used to have some files for training. The PowerPoint I used will also be uploaded here. The folder docs and images is used to hold source file of our online manual, but it is not recommended to open the folder directly to read the manual. If you want to see the online manual, please click the link here. It's a better way. You can click anything you're interested. Okay, then the README file. The README file is common on GitHub. It provides orientation for first-time users. Okay, let's start our demo. The first procedure, there are some preparations. The latest version of ArcGIS Pro is 3.2 now, and ArcGIS Pro should be installed, and the Special Analyst license should be active. Let me open my ArcGIS Pro, and here it is. We can click the setting, and you can see here my current version is 3.2.1, and here is the license. And the Special Analyst license is here. We create an ArcGIS Pro project at first. The project helps organize workflow, and I will name it as Lakeshore, and give it a pricing. Okay, the document is okay. The document. Okay. Then for the second procedure, we will download the source code and the data. This is the GitHub webpage, and there are two versions of our code. As you can see here, the main branch and the development branch. The main branch is a stable release version, and the development branch is a latest development branch. I suggest you to use the development branch currently. And there is a green button here, the code button, and we click the code button and click downzip. Okay. This is what we have downloaded. Let me refresh here. Okay. I'd like to copy this file to our project here. This is our project. I will put the file here and unzip the file. Okay, this is our file. Okay, let me open my ArcGIS Pro. Okay, this is my ArcGIS Pro. This is the layout I used to. In the center is the map view, and on the left side is the contents, and on the right side is the catalog. This is a folder, and we can find a folder named Lakeshore here. This is the project folder I have created before. Because I have copied our downloaded file under this project folder, therefore I can find it here. If you don't copy the file here, you should add a folder connection. You can right-click a folder and add a folder connection, or click Insert and add a folder here. Okay. Remember the folder organization. The ArcNET folder is the source code folder. Yes, this is the source code folder, and this one is ArcNLET-Py, we can see its suffix is pyt, which means Python toolbox. And let's click on the triangle in front of the toolbox. It will take some time for it to open for the first time. And okay, this is the toolbox. Let's back to our PowerPoint. There are 6 modules in ArcNLET-Py. The first module is pre-processing module. This is a new module. We will cover it in part 3. And the groundwater flow module is used to simulate groundwater velocity and velocity direction based on DM and soil data. The particle tracking module is used to simulate water particle movement from source area to water body, and source area means septic tank here. Then visual model module is used to model nitrate and ammonium reactive transport in vital zone from drain field to groundwater. This is an optional module, and the Lakeshore example is a simple demo, so we don't use this module. For transport module, it is used to model nitrate and ammonium reactive transport in groundwater. And the last module is load estimation module, and it is used to estimate mass loading to surface water bodies. Then before we start our demo, I will introduce code words. Let me open my ArcGIS Pro. We have added a lot of code words to ArcNLET. You can click on any module. You can right-click on any module and should view metadata to see them. Like here, you can see the meaning of each parameter. Besides, you can there's another way. Let me use groundwater flow module, and you can put your mouse on the blue icon. The software can display the meaning of each parameter. Besides, the software can also pump up warning and error messages. For example, the parameter smoothing factor should be greater than 0. If I enter a -1 value, and you can see the software give us an error. It said the smoothing factor must be greater than 0. Okay, let me introduce the structure of Lakeshore data. This is a folder we downloaded from GitHub, and this is the example data, Lakeshore example. First, we should unzip this folder. Okay, then we should find this folder in example here. Yes, it's here. If you can't find this folder, you should refresh here, and you will find this folder. Under this folder, there are 4 folders, and the first is example input. The files in the example input folder are the ones we need to use to run this demo. The files in the example output folder are the results of my calculation using ArcNLET previous. And the pre-processing module contains input and output data for pre-processing module, and the original data contains some raw data downloaded from internet for the study area. And we just need the data in the example input folder. We can see there are 5 files, and let me drag this file into the map. and we didn't need these two map file, and I will remove them. Okay, let me show the input data clearly. For DEM, we will this way. Okay, and for water body, we will use water. Okay. Yeah, this is the water body, and this is the DEM, and this is the septic tanks we can find. There is 265 septic tanks here. Next, I will introduce and run a module one by one. We will introduce the processing module in part 3, and let's begin with the groundwater flow module. Groundwater flow module is used to simulate groundwater velocity and velocity direction, and there are 4 inputs include DEM, water body, hydraulic conductivity, and porosity. You can drag data in directly from the map like this, or from the catalog like this, the DEM. Or you can click the drop-down arrow here and select the data like hydraulic conductivity, and or you can click the folder icon here and select the data like porosity. You can see each of our inputs has a format. For example, the DEM is a raster and the water body is a polygon. If the format is wrong, there will be an error message. For the output, you can just write a name here. In this case, the output file will be in a folder by default in the input file, or we can specify another folder with this folder icon, here example and example outputs. And write a name like demo velocity. This is demo velocity direction. Okay, I will ignore the optional outputs. And for the smoothing factor, I will use 15 or 50. Okay, then we click Run button here. The module then run, and we can click here to view details. This plays some of the outputs from the module when it is running. Okay, after the calculation finished, result will be displayed in this map view. Then, how the groundwater flow module works, I will briefly explain here. Let me use my PowerPoint. Okay, the blue line represents the groundwater table, and the yellow line represents the land surface. In general, the two lines are very similar, but the groundwater surface has greater undulation. Therefore, we smooth the ground surface, and after smoothing a specific times, we can get a plan very similar to the groundwater table. This is the basic principle we followed in our groundwater flow module. You will find more detailed instructions in Dr. Ye's video or our technical manual. Then we will go to the second module, the particle tracking module. This module is used to simulate water particle movement from septic tanks to water body. This module requires 5 input files, including source location, water body, velocity and velocity direction. Under porosity, velocity and velocity direction were calculated by the previous module. Let me enter these inputs: velocity, direction, and porosity. Okay, let me enter name for the outputs. Example. Okay, demo test. And let me click run. We can see this module run very quickly, and this is the detailed information, and this is the output. Each line in the map represents the transport path of a particle from a septic tank to surface water body. And then is the VMOD module. This module is used to simulate nitrate transport, and let's back to our PowerPoint. Okay, let's see this picture. VMOD module simulates nitrate and ammonium reactive transport in the vital zone from drain field to water body, while the transport module simulates nitrate and ammonium reactive transport in groundwater from the point beneath drain field in groundwater to surface water body. But the process in the VMOD in the vital zone is complex and requires many data to calibrate and validate the results. In our Lakeshore example, we will no longer use VMOD and we will run transport module directly. Okay, we will go to our transport module. 3 input files are required, and they are source location, water body, and particle passage. For Lakeshore example, let me input our result and here give a name to the output. Demo. For Lakeshore example, I will show the specific Z mode here, and then let me change the source dimension Y to 12. Okay, we leave the other parameters as their default values. Dr. Ye explained them in detail in his YouTube video, and I won't go into too much detail here. I won't click run here because our code can't run very fast currently compared to our old version. Let's go back to our PowerPoint. This is the results, and I ran the old version of the code written in Visual Basic .NET, and the Python version, and the tool and the ArcGIS Pro 30 times each, and this figure shows how long they took each time. We can find VB version of the code was calculated in less than 1 minute. Running just the Python code took about 4 minutes. However, under ArcGIS Pro environment, it probably takes 10 minutes. I think there are 2 reasons. On the one hand, Python inherently runs slowly than VB.NET. On the other hand, Python environment in the ArcGIS Pro may be affected by the software, such as the GUI interface and the diagnostic monitoring in the software. It's this one. This will record all the behavior in ArcGIS Pro. I think these are the reasons for the slowdown. And we will not wait. I will drag the outputs here. And let me show it clearly. I will this one. Okay, this is the output. This is the plume from septic tank to surface water body in groundwater. And then for the last module, load estimation module, let me drag the input file here. Transport module produces two files, one for the plume we just saw here, and the other for this information zip file. And the load estimation module will generate a name here. If you don't like it, you can change it yourself. I will just press the run button and okay, we can find the result here. Click parameter and output results. This is a CSV file. No. And these are the results. The first row we can find the water body feed number is -1, and this is for groundwater. And for the second row we can find the water body feed number is 30, and this is surface water here. Oh no. We can find for this water body the feed number is 30. And we can find the mass output load, input load, and mass removal rate. Thus, we can obtain the mass of the nitrate entering surface water body. Okay, and this is a Lakeshore example. The third part is about the new feature of ArcNLET-Py. First is merge water bodies. Let's look at this real situation here. This is a map from Google Earth. We can find a lot of houses here, and we use AA profile to introduce, and this blue line is a canal. Okay, this first figure is a DEM of AA profile, and we can see the canal here, and the unit of elevation is feet. If we smooth the whole area 20 times, we can't find our canal anymore in the smoothed DEM, like the second sub-figure. And if we use this smoothed DEM as groundwater table, we will ignore the effect of this canal. To solve this problem, we will add canal again to the smoothed DEM like figure 3. Then we smooth the merged DEM several times, and then we repeat this operation. Finally, we can see our smoothed DEM here, and our smoothed DEM has added the effect of this canal in the final sub-figure. This operation will more likely appear in our ArcNLET software. Therefore, we added a new feature for this. For this example, first we smoothed 20 times, and then we merge water body and smoothed 10 times, and then we merge water body again and smooth one more time. and in our ArcNLET-Py, we can see here. First, we smooth 20 times, and then we click merge water body and enter 10. Then we click add another and enter 1. In this case, the software will run. Merge and smooth as what we wanted. Okay, for the particle tracking module, there is a function named flow path truncation. And okay, this is the comparison of our result with the function on and the function off. Turn this function on makes the result look better. But turn this function on affect the calculation times. This function has no effect on our plume results. We introduce a new module in our ArcNLET-Py, which is named processing. It can this one. Okay, this one. It can extract soil properties from the online Sorghum database, and this tool is really useful. If you ever used ArcNLET, you will know that preparing the input data file, is a very time-consuming task. Therefore, we developed this tool. And this one. This is our start area. And I will put it here, the start area. And the second parameter is a projected coordinate system, and we choose this one for Florida. The top depths and the bottom depths indicate the depth of the soil properties to be extracted from the database, and here are different measures. I will enter the names here: demo, hydraulic conductivity, and demo porosity, demo soil type, and demo space, and click run. We can see detail here, and it will run very quickly. We just need to wait. Okay, let's result. We can see here. This is a soil type. There are 3 soil types here. There are 2 soil types here. Loamy sand and sand. And this is okay, this is the soil porosity, and this is the soil hydraulic conductivity. It's quite easy. And this is my presentation. Thank you very much. If you have any questions, please contact me, Mike, or Dr. Ye. Thank you very much.